So in the last section we talked about using Cramer's rule and determinants in order to solve a linear system of equations. And that does connect with something called matrices. But matrices on their own can also be used to solve linear systems. And so here what we're going to look at are matrix solutions to linear systems. And the first thing to talk about is something called an augmented matrix. In an augmented matrix, we take each equation and write it out inside the matrix with the coefficients and the constants. So in this case, the first equation on this system becomes row 1 of our matrix. I'm going to use R1 to stand for row 1. And in row 1, I'm going to put 1, 2, and -5 and -19 in that row to stand for the 1x, the 2y, the -5z, and the -19. And I usually put a separator line here between the coefficients and the constants. And then down in row 2 is where we put the second equation. We don't have an x here, so there's going to be a 0 in that part, followed by a 1, a 3, and a 9. And then equation 3 becomes row 3. There's no x or y, so we put 0, 0, 1 for 1z, and then 4. So we see I have a column for x, a column for y, a column for z, and then a column for the constants in the so-called augmented matrix. So if we can write the equations out in a matrix, then we can use that matrix to solve for the variables. Now before we do that though, let's look at this matrix here. And what I want to do is take this matrix and write it out as a system of equations. So kind of go backwards from a matrix to a system. Okay, so row 1 is going to turn into the first equation, which will go -1x. There's a 0 for y, so we have no y. We have plus 2z equals 9. Then the next row, which we'll call row 2, is going to be 4x plus 8y plus 7z is equal to -25. And then the third row, row 3, there's a 0 for x, so there's no x. We have 7y plus 2z is equal to 10. So that would be the systems of equations that goes along with this matrix. So the next thing we're going to talk about are matrix row operations. And there are 3 matrix row operations that work. The first one is any 2 rows may be swapped. And this is basically the same as if you were to interchange the original equations. The second row operation is every element in a row may be multiplied by a non-zero number. So this would be the same as multiplying all the numbers in the equation by something. And then the third row operation is 2 rows may be added to each other. And so we have these ways of indicating if we're doing swapping rows with kind of double arrows, means we're swapping those 2 rows, multiplying a row by a number, or adding 2 rows together. So here's an example we're going to do some row operations on, which is going to lead us into the way we're going to be able to solve systems by using matrices. Okay, the first row operation says to take row 1 and swap it with row 2. So remember, we can label this as row 1, row 2, row 3. So we're going to take the 2 rows and swap them. So if we do that, row 1 would go first, so that we'd have 3, 18, -12, 21 in row 1 now, and then 1, 2, -3, and 5 in row 2. and row 3 is the same. Okay, now what we have here is our new row 1, our new row 2, and our new row 3. The next step, I'm going to use the rows as I have them now swapped around. I'm not going to go back to where I started. So with the next row operation, I'm going to do a multiplication. I'm going to take 1/3 row 1, and that's going to equal a new row 1. So I'm going to write that down so you can see how I get the numbers. I take 1/3 times row 1, which is 1/3, again, the row 1 that we just created in our last step. So 3, 18, -12, and 21 are the numbers in row 1, and I'm going to multiply them all by 1/3. And that's going to equal my new row 1. That's going to equal to 1, 6, -4, and 7. So when I write out the matrix again, those are going to be the numbers that I put in row 1. And all the other rows are still the same. And so this is now our new row 1, and row 2, and our row 3. So we're going to go here to the next row operation. It says 2 row 2 plus row 3. And since I'm adding it to row 3, that's going to equal to the new row 3. So if we take 2 and we multiply all the numbers in row 2 by 2, we'd have 2, 4, -6, and 10. And we add those with the numbers in row 3. -2, -3, 4, and -6. And that's going to equal our new row 3. 0, 1, -2, and 4. So let's go about putting these into the 3 rows. The first row doesn't change. The second row is still the same. I didn't change anything there, but the new row 3 is going to look like 0, 1, -2, and 4. And so after doing all our row operations, this is going to be what the matrix looks like.